Hello, everyone. Welcome to today's webinar, Answering Natural Language Questions in SQL. I'm joined here today by Prabhat Ratnakaya, a data scientist at John Snow Labs. And before I turn it over to Prabhat, I'd like to go over just a few housekeeping items. So we welcome your questions today. Please type any of your questions into the GoToWebinar control panel on the side of your screen, and we will be answering all of these questions at the end of the webinar. If you have any technical difficulties, please shoot me an email and I'll try to help you out. My email is on the screen. And we will be sending out the recording of today's webinar, so you should receive that within the next couple of days. And at this time, I'd like to turn it over to you, Prabhat.
Thank you, Julia. Hello, everyone. So today we will, my topic is answering natural languages and questions in natural language questions in SQL. So, so I will go over my agenda. So this is my agenda. So I will briefly give an introduction to text to SQL. And so this is our latest annotator in Spark NLP. And I will go over the model that we have used, which is IRNet, and also I will describe how this will fit in our pipeline, in our Spark NLP pipeline. And after that, I will do a live demo on how this all works. Okay, let's get to it. So what is text to SQL? So as all of you know, most of the existing databases that we use in many industries like healthcare, sales, and also financial industries, we already use relational databases. And at the time, even though we have some systems to get the data out, I mean, we have web apps, we have mobile phone apps, but the thing is, most of those things are pre-programmed. So the questions that we can ask from the database are limited and it's pre-programmed. Let's say in those industries, there are many more questions that cannot be pre-programmed. So, but to get those data out, people need to know about SQL, but not everyone knows SQL. So what is the solution here? So the solution here will be translating users' queries spoken in natural language into SQL. So that way we can use any dynamic query without knowing without the knowledge of SQL to get data out from those relational databases. So so let's look at some use cases of text to SQL. So this is just the top of my mind. There are many more so we can use this as a data retrieval tool for sales and marketing. So usually those people in sales and marketing, they might need to do a lot of querying of their existing customer base and also new leads. So but the systems that we have already are pre-programmed to get some of the queries, but not all of them. There might be some they want to know what happened on a day which has let's say 10 people, but if we don't have that capability in our existing system, then they will fail to get that data. So we can use this to do that. And also in healthcare data, most of the data is in electronic health record format, so mostly in databases. So we can use this in healthcare data as well. So, and also as an data analyst helper in financial sector. So these are some of the use cases of text to SQL. Okay. So let's define our problem. So we can say that given a database or a table, translating humans' natural language query into SQL is our problem definition. So what we have come up for this is a new text to SQL annotated in our Spark NLP library. So this is the newest addition to our Spark NLP library. So we have chose this model called IRNet. So it is by Go and Chang. So this method achieved the state-of-the-art accuracy in 2019 by the time it was published. And this is able to construct very complex queries given questions, and it supports SQLite databases at the moment. And we have used this data set called Spider, so to pre-train this annotator. So this is a cross-domain text to SQL dataset. So it has around 10,000 questions to SQL pairs, and over 200 databases with multiple tables covering more than 138 different domains. And if we look at the performance of this method, as you can see in this Spider dataset, there are three categorizations of question hardness. So it is able to exactly match the given SQL for 70% of the easy ones, and for medium with medium difficulty, it's 50%, and for hard questions, it's around 40%, and for extra hard questions, it's around 20%. But most of our day-to-day questions fall under easy and medium questions, difficult questions. So I think this will be a better model to model all of our questions to SQL needs. Also, you can download this Spider dataset if you want from this link I have provided. So it is a open dataset. So I will give you a quick overview of this IRNet model. So this consists of 4 major components. So first, they have this intermediate representation. So and they have a schema linking component, and also they have this encode decoder model, and they also have a cost to find framework. So I will explain each of these components in detail. So they have introduced this intermediate representation. So it is called SQL. So this serves as the intermediate representation between natural language and SQL. So what they have tried to do here is, so when you say something in SQL, something in natural language, it does not directly translate into SQL. So what they wanted to solve that issue with it's not directly translating into SQL. So what they have done is they have come up with this intermediate representation that we can first we will translate our natural language question into this intermediate representation, and later on we will convert this intermediate representation into SQL. So they have brought in a middleman to help with this mismatch between SQL and natural language. So this is a context-free grammar. So you can read more about it in the paper. So they have also another component called schema linking. So goal of schema linking is in this model is to recognize columns and tables mentioned in the question and assign different types to the columns. So this is like a pre-processing step. So let's say we have a question and there might be some clues what this question refers to. So in here we will in this paper they have used something like ConceptNet to match questions into columns and tables. So as an example, we can say that let's say somebody says that show me all the pizza places in New York, but in the database we don't have any New York, but what we have is a city. So we need to map that New York into city. So to do that, we can use this. We have used this ConceptNet, so we can link that to this city column. So something like that. So yeah, we can think this as a instantiation of entity linking in this context of text SQL. So in here, entity is columns and tables and values. So and also they have this encoder decoder model for this IRNet model. So they have experimented with two different methodologies. So the first one is they have experimented with both encoder and decoder with LSTM architecture. So in here, the encoder is a unidirectional one, and the decoder is a bidirectional LSTM. So this is their initial methodology, and later on they have tried replacing this LSTM encoder with a BERT encoder and keeping the LSTM decoder as it is. And they have shown that this works better. This BERT encoder gives a little bit of accuracy boost. But in our implementation, we have used this LSTM to LSTM decoder architecture. We will be implementing this BERT to LSTM decoder architecture in the next releases. So in the encoder, there are two subparts. So one will be encoding the natural language question that the user provides. So in here, all the previous components that I mentioned will come into play. So like the schema linking, and also and then we have a schema encode. So what this will do is this will encode the table and database schema, and given those two encodings, we will try to decode a SQL query, which I mentioned earlier, the intermediate representation. So we will try to decode a SQL query from the natural language question and the schema provided. So also this model has another component called cost to find framework. So what this will do is, in the previous step, we have decoded, we have generated some SQL queries based on the question and the schema, but we need to convert this into an actual SQL query. So we can do this in two stages. So that is what this cost to find framework means. So first, it will decode. It will output a skeleton decoder based on the SQL query, and then a detailed decoder is there to fill the missing details, like the columns and table names. So that is how the cost to find framework works. So this is the overall architecture of IRNet. As you can see, at the bottom, you can see that we are feeding the question, and also you can see the type. So this type is we derive this type from this entity schema linking, and we will feed both of those question and type into the natural language encoder, and we will encode that, and we will pass the encoded question and type into the decoder, and we will use SQL decoder in order to decode a SQL query. In here also we have used this memory method, and so to do that we have used some pointer networks in this IRNet method. So either it will query from the memory itself, and or it will look at the schema and choose which column or which table is the best match for this given query. Okay. So this is how we have implemented the SQL Text SQL Pipeline in Spark NLP. So as I mentioned earlier, we have two different encoding tasks at our hands. So first one is encoding the question, and and the next one is encoding the schema. So for question encoding, what we will go through is we will go through the normal process of so we will first assemble the question into a document, and we will try to detect the sentences within the document, and afterwards we will tokenize the sentence, and then we will generate word embeddings for this given question. And for the schema related components, we have a text to SQL schema parser. So what this will do is in this spider dataset, there's a specific format for tables. Tables means schema. So given if we have a schema in that format, we have a parser to parse that and get the metadata out from that schema. And this schema parser will output a chunk Spark NLP type, because there will be names like something like a place ID, something like with 2 words. That's why we are using chunk. And in order to use the tokenizer, we need to convert this chunk into a document. That's why we are using chunk to doc. And we will go through the same process again. We will go through the tokenizer, and we will use the embedding. And also next we will convert that embedding into chunk embedding based on the chunk output by this SQL text to SQL schema parser. And then at last we have our text to SQL model. This will take in question, document, and question embeddings, and table metadata, and also table metadata embeddings. And it will output the SQL based on the question. So I know this is quite a lot to get the SQL from a question. We are working on a pre-trained pipeline for this. So that way, all of this will be pre-trained, and you won't have to do any of this, and you just have to use the question, and it will automatically give you the SQL for that. So we are working on that. Okay, so I will move on to the demo. Okay, so this text to SQL annotator is still not released in our Spark NLP library. It will be released on the next major version, which is what we have is 2.6, and it will be released on the next version. So you can see this in next version. So first we will import all the annotators here, and in here we will create this Spark session, and I have run those two beforehand because it takes a bit of time. And here we have the Spark NLP pipeline for question related information. So run that now. So here we have the document assembler, sentence detector, tokenizer, and the word embedding. And then we have the components for schema related information. So in here we will use this schema parser and SQL model, text SQL model. So you can see that we have the schema parser here, and we input the schema as JSON. You can generate this JSON from this scripts given by Spider dataset and their GitHub repository. So you can convert any SQLite database into this JSON format. And as I mentioned earlier, we will convert that into a doc and then a tokenizer. We will pass it through a tokenizer and word embedding, and we will convert that word embedding into a chunk. And at last, we will feed all of those transformed columns into text SQL model. And we will use a light pipeline for this one, so we can annotate on the fly without having to do it in batches. So we pick the light pipeline. So I have chosen sample database for the demo today. So this is from the Spider dataset. So this is a database of a HR firm, so HR department. So there are 7 tables in this one. So we have locations, we have countries, and we have regions in this table, in these 3 tables. And also we have employee related information in here. So we have job history, which has the jobs and end dates of their previous jobs. And we have the employee details, like their personal details, like phone number, first name, likewise. And also their current department name and their manager and the location. And also we have the job title, job title, salary, and salary information of each of these employees. So let's run some queries on top of this database. So I have this SQLite database in this folder. So let's create a connection to that so we can run on top of that. So I have this helper method. So what it will do is it will take the question in and it will annotate using this SQLite annotator, and it will output the SQL. And I will print this SQL here, and I will show the query here. So this model supports a variety of SQL query types. So let's say we want to display all information about a table. We can ask this. So then we can ask display all information about employees. So then it will output something like this. So it will select each column, and it will give. So this is the SQL output from the model, and this is when we run it on top of this this database that we have already created the connection to. So we can do something like this as well. So let's say we want to select some columns from a table. So let's say we want to display the first name and department name for each employee. We can do that as well. So what it will do is it will select first name and department name, and it will create this join based on this, and it will return the required information from the database. So we have run this query on top of this database, and this is what we get. And also we can use some constraints to limit the number of questions. So let's say we want to look at the first name and last name, the full name and salary for those employees who earn below 6,000. So we can do that as well. So we have the constraint of employees who earn below 6,000. So that is the constraint. When we give that, it will automatically it will output this query with this salary constraint, and also we can do something like that this as well. So we want to look at first names and department numbers for employees with last name McEwen. So if we do this, it should filter out employees who has the last name McEwen. And also let's say we want to look at salary and manager number for those employees who is working under a manager. So this is a bit of tricky SQL, because what we are asking is who is working under a manager. So this shouldn't be null. Manager shouldn't be null. So this is kind of a tricky question, but it's managed to get this. Okay. So let's say we have multiple constraints. So we can do something like this. So we can ask that what are the first and last names for those employees who works either in department 70 or 90. So this is a O clause. So we have to use this O with two constraints, either it is 70 or 90. So we can get the names. And also we can use the operation like in here. So to get something like that, so we have to ask, we can ask something like this, when is the hire date for those employees whose first name does not contain the letter M. So for this, we need a query with like. Yeah. So this will output something like this. And also there might be some instances that we will need queries with between. It might be a range of numbers or range of dates. It can be either. We will look at both of those. So let's say we want to filter employees in a range based on their salary and get their phone numbers. So we can do something like this. So this will filter out based on this range and use in between keyword. And let's look at the same thing for a range of dates. It will work the same, but there are no records in that. Yeah, and another instance is using this having keyword. So I'm sure most of you know about having keyword. So the difference between having and where. So in where keyword, the comparison is done before group by, and with having keyword, it is done after summarizing by group by. So in here we will need the having keyword because we are asking the IDs of departments who where the manager is managing 4 or more employees. So this needs to be done after grouping by. So let's see. Yeah. So because this having keyword is done after grouping by, we can't use where here. So this is able to do this here. And let's look at another example of having. And also we might have some queries with group by, and we can do that as well. So if you want to display country IDs and number of cities for each country, that is a group by query. So we can do something like that as well. And we have a similar query here. So that this is also a group by and with a max. And let's say there are more than 2 tables that we want to join, and this is capable of that as well. This can handle multiple joins. Let's say we want to find the employee with ID and name of the country presently where he or he is working, and this might need 2 or 3 joins because there's the country and employee information and personal information. So let's run this as well. Yeah, there are 3 joins from 4 different tables. So we can do something like this as well. We have another example on this. Yeah, in here it's only there's only one join, but with a constraint. Yeah, I think that's all for the demo, and I will take any questions you have next. Any questions?
Awesome. Thank you so much, Prabhat. We did have a couple questions come through, which I will go through now. And I did also want to let everyone know while you're typing in any other questions that we do have NLP Summit right around the corner. So in about 3 weeks, we're hosting this week-long event, and it's going to be 4 days, and it's also going to have 50 plus sessions, a hackathon, a lot of panel discussions, and general admission is free. So if you haven't already registered, please be sure to do that. The website is www.nlpsummit.org. And I will also paste that into the chat here. And we have quite a few questions that came through, so I'm going to go through these now. One of the questions that was asked, I do not see text to SQL on Spark NLP website. Has this already been released?
Actually, no. This will be released on the next major release. So yeah, look out for the next release. So this will be released on the next major version.
Awesome, cool. So they'll look out for that. Another question that came through was, would this work with doctor notes / medical notes? So the person that submitted this question, I think this may have been relevant to what was being displayed at the time. So if you don't mind giving us some more clarity what that was regarding, unless that's significant.
Yeah, so this will work with any kind of document, any kind of databases. So we are currently working on some industry focused, I mean healthcare, financial, and sales focused pre-trained models. So then you can use those without any training. So yeah, it will work on healthcare data as well.
Awesome. Someone asked, how can I access the notebook from the presentation?
We will release it after we release the text to SQL on our next release, and you can access this notebook from our GitHub repo. There's this NLP workshop. You'll be able to. We will release it here. Release it there. This notebook.
Awesome. And then someone asked, how do you support querying against Hive?
Sorry, can you repeat that?
How do you support querying against Hive?
Actually, at the moment, we only support SQL Lite. We do not support Hive. So yeah, we only support SQL Lite DBs, relational DBs as of now.
And another one that came through, how are SQL queries ranked by difficulty in the training data?
Yeah, so something like a select from table would be ranked as a easy question, and also with a query with a one join will be ranked as a easy question, and if that have something like a having clause or something like ordering and multiple joins, it will be a medium kind of question, medium difficulty question. And there are some hard questions which does not mention any table name or column name or anything related to the schema in the question, and we still have to match that into the database. So those kind of questions will be hard questions, and there are some extreme hard questions as well with multiple joins and multiple constraints.
Awesome. We're at time now, but I think we can answer one more quick question that came through. Can the system recognize when a prediction is likely to contain errors?
Not at the moment. Yeah, not at the moment. If it is.
Awesome. So there's a couple questions we didn't get to. We can definitely follow up with those offline. If there's any other questions that anyone had, feel free to submit those and we'll definitely follow up with you. But at this time, thank you so much for joining us today. Thank you, Prabhat, and be sure to register for NLP Summit. There's going to be a lot of great sessions there, so you definitely don't want to miss out on that. So we will see everyone there. Thank you all.
Thank you.
Enjoy the rest of your day.